All right, let's take a look at the video that quiz. Sorry, tongue-tied for a second. The quiz that you just took, okay? We are going to go over it in class. Also, I will take pictures and post those as well onto Blackboard, and I will have the link of this video. Again, it's up to you if you want to watch the video, or if you just want to watch it, go and look at the pictures of the answer key, okay? Let's begin. Number one shows you that there's a table over here, and there's 3 different balls, ball A, B, and C. If a ball rolls off a table with 3 different speeds and follows the trajectories below, A, B, and C, let's go ahead and neglect air friction. The time between leaving the table and hitting the floor would be the greatest for none of these trajectories, because they will all hit the floor at the same time. Why? If they leave from the same height at the same time, they're going to take the same amount of time to hit the ground, okay? Next one, number 2. Number 2 says here, determine the launch speed of a horizontally launched projectile that lands 26 meters from the base of a 20-meter high cliff. You must include SI units. Okay, first step. Let me go ahead and draw my cliff. There goes the ground. Determine the launch speed of this horizontally launched projectile. It's going to form a parabola when it's launched. And it lands 26 meters from the base. So from here to here is 26 meters. The height is 20 meters. Question mark velocity. First step I would do would be my X and my Y T-chart. Distance, velocity, time. D, VI, T, A, and VF. VI is 0. A we know is negative 9.81. VF was not given to us. T was not given to us. This is what we're looking for. The velocity horizontally. The distance was told 26 meters, and the height was a distance of 20. So I'm going to grab my highlighter, and I'm going to highlight the side that we're looking for, which is the X component side. Can I answer this equation? No, I cannot. They did not give me enough information here. So I'm going to have to go to the Y, solve for this T first, plug it in over here, and then solve for the X. So let's do that. Step 1. D equals 1/2 AT squared. Distance vertically is 20 equals 0.5 times, yes, it is a negative 9.81 times T squared. Divide by 4.905. That cancels out. Divide by 4.905. Oops, sorry. 20 divided by 4.905 equals 4.077 equals T squared. Not my answer. I need to square root it. So the T comes out to, let's square root that, 4.077, 2.012. Now I'm going to put right here 2.02, just going to round it, 2.02. Now I can go ahead and I can do part 2. D equals V times T. And I know my T now. The D is 26 equals V times 2.02. Divide by 2.02, cancel, divide by 2.02. So 26 horizontally divided by 2.02 equals a velocity of 12.87 meters per second. Okay, I will take a picture of this and post the picture as well. Next one, number 3. Number 3 states here, a rock is dropped from the top of an 80-meter tower And at the same time, a ball is thrown from the top of the tower in a horizontal direction. Air resistance is neglected. It says here, the rock hits the level ground straight below, and the ball hits about a distance of 40 meters apart from the rock. The horizontal velocity of the ball thrown was approximately about what? Okay. Step number 1. Oh, this came out. This should have scooted over. 40 meters per second. So they actually gave us A, B, C, D, E answer choices. I'm going to draw my building. And I've got 2 rocks. One is going to fall straight down. One is going to be thrown out horizontally and land out here. Now they told me that the distance that it landed horizontally away was about 40 meters away from it. And they told me that the tower was a height of about 80 meters tall. We want to know, what is the horizontal velocity? Question mark V. What I would do, step 1, would be my X and my Y component. DTV. Question, X, 40. DTVIAVF. X, 9.81. 0, X, 80. I would grab my highlighter. What side am I looking for? I'm looking for my X side. Do I have enough information to answer? No, I do not. I need to go to my Y, find my T, plug it in, and then I can solve over here. Okay, so let's do that. Step 1. D equals 1/2 AT squared. Or 80 equals 0.5 times 9.81, I know it's a negative, times T squared. Divide by 4.905, cancel. Divide by 4.905. 80 divided by 4.905 comes out to 16.31. Remember, that is T squared, so we need to do the opposite, which is square root it. So the square root of 16.31 comes out to about 4.04. So I'm going to plug it in. 4.04. 4.04. Now come over here and do part 2. Part 2 is D equals V times T. Remember the X component equation. It's in your notes. Which is 40 equals V times 4.04. Divide by 4.04 to cancel. Divide by 4.04. 40 divided by 4.04 comes out to about 9.9, which is closer to 10 meters per second. That's my correct answer. All right, next question, number 4. Number 4 says a blank is an arrow that describes magnitude and direction, a vector. Number 5, a stone is dropped into a deep well and is heard to hit the water 3.41 seconds after being dropped. Determine the depth of this well. How deep is it? Must include SI units. Okay, the stone is dropped into the well. So let's go ahead and do a drawing. All I know is that the amount of time that it was in the air was 3.41 seconds. That's all I know. Determine how deep did it fall. What was the distance? Okay, well, X and Y component. Do I have anything regarding the X? I do not. Okay, I'm looking for the Y component distance. The T was 3.41. A, the moment it was released into the air, is negative 9.81. The VI was 0 and the VF was not given to me. Alrighty. So let's see. Could I use the x component equation in our notes from Unit 3? That equation says d equals 1/2 at squared. Do I have the distance? That's my unknown. I have the a, I have the t. I should be able to use this equation to find the distance of how tall this well was. D equals 0.5 times 9.81 times 3.41 squared. So let's use that equation so we can solve for it. I'm going to come over here. Let's see, 3.41 times 3.41. That comes out to 11.63. I'm going to round. Times 9.81 equals times by 0.5. The distance came out to 57.04 meters. If you wrote down, that's correct. If you gave me a negative because it went in a downward direction, that would work as well. I didn't, you did need to put meters. That needed to be on there for distance, okay? That's what I was looking for. That's what I was looking for. This was extra. Thank you if you wrote that. Let's keep going. Next one, number 6. Determine if the following statements are true or false. All right. A projectile does not have to have a horizontal motion. True. What about if it's just dropped? There's no horizontal motion like the previous question. Next one. A falling skydiver with an open parachute is in free fall. False. It has a parachute. It's slowing it down. A vector quantity always has a direction associated with it. True. A scalar quantity has a direction associated with it. No, it does not. Scalars do not have direction. Vectors can be represented by an arrow. The length of the arrow represents the vector's magnitude, and the direction of it pointed represents the vector's direction. True. All of that is true. A projectile does not have a horizontal velocity. A projectile does not have a horizontal velocity. False. A projectile with a rightward component of motion will have a rightward component of acceleration. False. Because it's going to be constant. That's why it's not going to be accelerating.